Okay, in the first lab we'll do in the organic lab, it's a melting point lab, and what you'll do is get one of the melt temps, and we have 3 varieties of them in the lab, and it doesn't matter which one you use, they all work the same. They all have the dial on them. They all have a spot for the thermometer, a spot for the sample. The only difference is between the color and how much safety guard there is around the heating element. And I'll demonstrate with the oldest one here so you can see where everything goes in it. But the first thing you need to do is plug it in, and since we have a dial on the melt temp, we don't have to worry about the transformer we talked about in the last video. All we need to do is plug this into a regular wall outlet and plug it into the back of the melt temp, and then when you turn it on, you'll see a light come on, and when you use the melt temp, what you do is look into the glass eyepiece, and you'll see the bottom of the capillary tube that you've inserted into the melt temp. Now when you start, there's no way to know how high to turn up your melt temp as you're doing your melting point run. So what you need to do is start with it low in the 3 to 4 region, and if the temperature doesn't rise fast enough, then turn it up higher than that. But when you're using the melting point apparatus, you'll put your thermometer in the big hole of the heater block, and then to make a melting point sample, what you'll do is get a capillary tube, and the capillary tubes are over underneath the green board, chalkboard, where we talked about where the common equipment was last time. And what you'll do is take a capillary tube and jab it into the sample that you want to get the melting point of, get a little bit of the compound in the capillary tube, and then usually you can just tap it down on the countertop, and you'll get enough of the compound down in the bottom of the tube to put into the melting point apparatus. Now when you add it into the melting point apparatus, there's a place for 3 capillary tubes going across there. So in the first lab where you're doing a melting point on different things, you can do 3 of them at the same time. Start with the lowest melting compound, and you'll work your way up to the highest melting compound. As you're going along, if you're doing a known like this one, acetaminophen, we know what the melting point of it is, so we can watch the thermometer and get it within 10 or 15 degrees of where acetaminophen melts, and then slow it down so it goes up about 1 degree a minute, so that we get a really good melting point on our sample. If you're going up too fast, the block will be at a certain temperature. The thermometer has a lot more glass to it. It'll take longer to equilibrate to that temperature, and the capillary tube, very small, will be at that temperature relatively quickly. So it'll be melting long before the thermometer shows the actual temperature for your sample. So when you're doing a known, you turn it up, watch the thermometer, watch the temperature rise on the thermometer till you get close, and then slow it down so it only goes up 1 degree or 2 a minute. If you're doing an unknown, what you want to do is make 2 samples, and the first sample, what you'll do is turn it up really high and get it to quickly melt, so you know roughly where it melts, and then you will run a second one where you get it within 10 or 15 degrees of that temperature that it melted the first time, and then slowly raise the temperature up from there at about 1 degree a minute or so you get a good melting point on your unknown, and then you can use that to identify your unknown. With a solid, the melting point of that solid, no matter where that sample came from, it will always melt at that certain temperature. So you know, if you have a pure sample, that it always melts at the same temperature. If you have a mixture, it will not melt at that same temperature. It'll melt at a lower temperature over a much wider range. It won't be 1 degree or so range of melting point. It may be 10 or 15 degrees from when it starts melting to when it finishes melting. So you can use that to identify whether you have a pure sample or not as you're doing a melting point and trying to identify your unknown.